Hello and welcome to the topic Introduction to the Atom. In this lesson, we're going to learn how are atoms different. Specifically, what we'll learn are two things. One, what happens during nuclear decay, and two, how does a neutral atom change when its number of protons, electrons, and neutrons change. So let's go over some key vocabulary. The first is atomic number. Atomic number is the number of protons in an atom of an element. Periodic table. In this example, you'll see it right up here. You also have an isotope. An isotope is atoms of the same element, but they have different numbers of neutrons. Mass number is the sum of the number of protons and neutrons in an atom. The average atomic mass is the average mass of the element's isotopes. Radioactive are elements that spontaneously emit radiation. Nuclear decay is the process that occurs when an unstable atom nucleus changes into another, more stable nucleus by emitting radiation. An ion is an atom that is no longer neutral because it's either gained or lost electrons. So let's go ahead and begin our lesson. So we have the parts of an atom. The mass of electrons is much smaller than the mass of protons and neutrons. All right? Most of the mass in an atom will be found in its nucleus. All right, so you have the proton, the neutron, and the electron. Remember that the electron is negative, the proton is positive, and the neutron is neutral. And look at this relative mass, 1, 1, and 1, 1,840. The number of protons in an atom of an element is its atomic number. The atomic number is the whole number listed with each element on the periodic table. Remember, my other example was in the upper corner, and now this one is in the lower corner. But it's usually a whole number. Atoms of different elements contain different numbers of protons. Always remember that. That's how they kind of organize it. Atoms of different elements contain different numbers of protons. So here we have an example of carbon, nitrogen, and oxygen. You can see that carbon has 6 electrons and 6 protons, so it's balanced. Nitrogen has 7 electrons and 7 protons, balanced. And oxygen has 8 electrons and 8 protons, also balanced. Neutral atoms of different elements also have different numbers of electrons. In a neutral atom, the number of electrons equals the number of protons, just like I showed you just a minute ago. Therefore, the number of positive charges equals the number of negative charges, so it's balanced. And now you also have this situation where it may lose an electron and become positive ion. So atoms of the same element that have different numbers of neutrons, the neutral charge, we call these isotopes. Now, isotopes are atoms of the same element, again, that have different number of neutrons. So you can see right here, carbon 12, carbon 13, carbon 14. Their electrons and protons are the same, but they have different numbers of neutrons. Many elements, like carbon, they have many isotopes. All right? So this doesn't have to do with their charge, it just has to do with the number of neutrons. An ion has to do with their charge. Remember what I said, a positive ion is where it lost an electron. This is all about neutrons, and different numbers of neutrons are called isotopes. So why don't you go ahead and circle that part. Different numbers of neutrons. The mass number of an atom is the sum of the number of protons and neutrons. All right, so mass number is equal to number of protons plus number of neutrons. An isotope is often written with the element name followed by that mass number. So for example, see carbon-12, you can see it has 6 and 6. Carbon-13 has 7 neutrons and 6 protons. So they just use that mass number to kind of name these different isotopes. So these carbon ones that I was showing you as examples, they are actually naturally occurring. Carbon-12 is probably the biggest one. But again, just remember what you need to know is isotopes is all about the number of protons and neutrons. So when that number of neutrons changes, it's a different type of isotope. And they name it usually with the atomic mass, which is the number of protons and the number of neutrons. All right. The average atomic mass of an element is basically the average mass of the element's isotopes weighted according to the abundance of each isotope. Remember I said how that one carbon-12, there's a lot of them, and there's only a few carbon-13s. So basically it's a math formula where they take the average according to how many of the different types of isotopes, etc., and they kind of figure this all out, and they come up with the average atomic mass. So carbon is 12.01, and helium is 4.003. There was a woman named Marie Curie who was a scientist, and she called elements that spontaneously emit radiation as radioactive. She was the one who discovered this. She said, well, they're radioactive. They're emitting this harmful radiation. Henry Becquerel and Pierre and Marie Curie discovered that radiation released by uranium was made of energy particles. So they were the ones that actually discovered this. And that this radiation came from the nuclei of the uranium atom. So when uranium atoms release radiation, it actually changes to a different element as it starts to release this radiation from its nucleus. And we call this process of an unstable atomic nucleus changing into a more stable nucleus emitting radiation. We call this nuclear decay, as it starts to get rid of its unstable atomic nucleus, or radiation within the unstable atomic nucleus. It starts to become more stable. That process of reducing the radiation is called nuclear decay. Now, when nuclear decay happens, there are 3 different types of radiation it puts out. There's alpha, beta, and gamma. All right? Those are the 3 types of radiation. So nuclear decay, 3 types of radiation, right? Alpha, beta, gamma. An alpha particle is made up of 2 protons and 2 neutrons. So when an atom releases an alpha particle, its atomic number will decrease by 2 because it just got rid of 2 neutrons and 2 protons. When beta decay occurs, a neutron changes into a proton, and then it releases a high energy beta particle. All right? So here's the unstable nucleus, and you can see one of the neutrons changes into a proton, and then a beta particle shoots out. And the atomic number of an atom actually increases at this point. So because it has more protons. And because gamma rays do not contain particles, they're just rays or energy, the release of the gamma ray doesn't change anything. So you go to unstable, no changes in the proton or neutron, it's just that the gamma rays are released. So, key concept check, what happens during nuclear decay? Well, it is when an unstable atomic nucleus changes into a more stable nucleus through emitting radiation. And those 3 types of radiation that it produces are alpha particles, beta particles, and gamma rays. So nuclear decay is when this unstable atomic nucleus changes into a more stable nucleus by emitting radiation. And that radiation comes in three forms: alpha particles, beta particles, and gamma rays. The energy released by radioactive decay, remember, I think we all know this, it's not very good for us. It can be harmful, but it can also be beneficial. So there are the good and the bad of radiation. We use some radiation, for example, for chemotherapy. Chemotherapy is kind of a radiation therapy that destroys cancer cells within our body. But it's still also very toxic to our body. When a neutral atom loses one or more electrons, right? Now it has more protons than electrons. It starts to have a positive charge. And an atom with a positive charge is called a positive ion. An atom with a positive charge is now called an atom, or an ion. So this is an example where you had the atom with 11 electrons, 11 protons, and then it lost one electron. Now it's become a positive ion. Now when a neutral atom gains one or more electrons, it now has more electrons than protons. So now it has a negative charge. And an atom with a negative charge is called a negative ion. So in this example, you had 9 protons, 9 electrons, and then another electron came in, and it became a negative ion because the electrons outnumber the protons. So how does a neutral atom change when its number of protons or electrons changes? When an atom loses electrons, it has more protons than electrons. So it has a positive charge. That means we call it a positive ion. When an atom loses protons, it has more electrons than protons. So that means it has a negative charge. And we call this a negative ion. So losing electrons means it has more protons, so it's positive, so it's a positive ion. Losing one or more protons means it's negative, so it's a negative ion. So ions are all about losing either electrons or protons, so there's no balance. When there's no balance, it becomes an ion. Depending on what it loses, it could be a negative or a positive ion. So in summary, remember, different elements contain different numbers of protons. All right, that's how you distinguish between the elements. Two isotopes of a given element contain different numbers of neutrons. Isotopes have different numbers of neutrons. When a neutral atom gains or loses an electron, it becomes an ion. So there's your lesson for how are atoms different. We hope you enjoyed the lesson, and we'll look to see you in the next one.